Okay, good morning or afternoon, ladies and gents. For today's lesson, we're going to work on the opposite of what we did in the previous one, which is the subtraction of vectors. So what we were aiming to do today is we're going to recognize how to apply that same triangle rule to vectors to determine the difference of vectors. Now recall, if B is going in a direction, the negative B must go in its exact opposite. That means that if A plus B is the same as B plus A. But when you're writing in this next bit here, and please stop and pause this to write this down, A minus B is the same as A plus negative B. If you're going to write this, just like this here, you'd go minus B plus A. So therefore, if vector A is going in a direction and B is going in the opposite, then A minus B, as we show here, we draw A first, we connect minus B, and then put our resultant down here, A minus B. This one's a little bit more straightforward now that we've gone through our cosine rule. So for our first example, calculate the resultant of P minus Q with vector P going in a positive direction at 4 and Q going in a positive direction of 4. So, because it's P minus Q, we need to find the opposite of this. So negative Q goes downwards, so opposite 180 degrees, but still in the same strength of 4. I would suggest you draw this up so you can see what it looks like. So we go P plus minus Q. Because it's going across to 4 and down to 4 over here, we also draw up how high or how low it's going to go. You can see by literally drawing it up. So 4, negative 4, in this case here, because it's going upwards at 4, it technically goes up to a level at 3 and down to the level at about 6. Going downwards this way, goes down a further 2 at 8 over here. Now, if you see our drawing, you can effectively see that it is just before our x-axis begins. So when we're drawing this, guys, we're not trying to look at the total vectors everywhere. For P minus Q in this case, we need to create our own new triangle for this. This is where this cut part comes in. We could muck around with all of this, but honestly, why muck around when you need to? If we just need to find the magnitude and the direction, let's use the substitutions we know. So for P minus Q, we've got our unknown angle, our magnitude here, but we've just given ourselves our x and y values. X value of 8, y value of 1. It's fantastic. We can then substitute this into our formulas. Magnitude, direction. R equals the square root of x squared plus y squared. This gives us the answer of square root 65, leaving in its absolute. For our angle, inverse tan of y and x, in this case 1 over 8, which is 7.125 degrees. Therefore, the resultant vector of P minus Q in polar form is root 65 at 7.125 degrees. Sounds easy, always gets harder. Let's look at our next one. If the vector A in polar form at magnitude of 35 degrees at the direction of 130 degrees, and vector B at 40 at the direction of 50 degrees, find the difference in these vectors. So, draw your diagram. First up for vector A, this is our starting point here, and you're going to see it's a bit of a messy drawing, but work with me. Vector A goes off in an angle of 35 degrees, sorry. Magnitude of 35. So remember that. So if our total over this, and here we go. So for B, because we're trying to find the difference, B could go up 50 degrees, but because we're going in a downwards way, add 180 degrees to it, going down this way. This is going to give us some information. Our resultant is A minus B. You can see for our points, I've got points A, point B, point C. We can use some information here. We know from our previous one that we need to know at least 2 known side lengths and 1 angle. Well, we've got 2 side lengths, A and B, 35, 40. We can't use this to work out our missing angle here. We do not know what this angle could possibly be here, but we can use this. Because they're going up and connecting into 2 separate Cartesian planes, if we know that collectively this is going to be 45 degrees here, that means that this will have to be 45 degrees here. If it goes up at an angle 50, that means this has to be an angle of 50. And this means we can work out what's left over. 180, 50, 35. Let's see what's left over. In this case, we have an angle, 50, an angle of 80 degrees. Think about it. 50 degrees, 50 degrees. This reflected must also be 50 degrees here. Angle of 80 degrees. Now that we know this, we can start applying our cosine and our sine rule to calculate our unknowns. So, to work out the resultant of A minus B, we put in our values. R squared magnitude equals A squared plus B squared minus 2 times A times B, cos of angle. 35 squared plus 40 squared. Take 2 times 35 times 40 times cos of 80. This gives us a huge value here. We square root it to get our R on its own, and therefore our magnitude is 48.361. Now, we have to find the direction for A minus B. And we do this by applying our sine rule. If you can't read this properly, pause the video, rewind it by a few seconds, do it again. So our sine rules shows, and remembering, I labelled them A, B, C, that B over sine of E of CBA is the same as R over sine of our total degrees, 80 degrees. So we substitute our values. We know B is equal to 40. We know R in this case is 48.361. Sine of 80, we can just rearrange it there. And this gives us the angle of inverse sine of 40 over 48.107, giving our degrees at 54.543 degrees. Last bit here though, just going into this point here, we would need to include the extra 130 degrees used at this final curvature. So in this case, our final angle is going to be this plus 130 degrees. 130 plus 54.493, 184.543. Apologies there, guys. Therefore, the resultant vector of A minus B is magnitude 48.361 at the direction of 184.543 degrees. I'm just going to go back to that little drawing I did before. You're going to see this again. we've worked this out. We need to show our total over here. This is where it's coming from. And if you're still a little bit unsure, please be aware the notes for this are also up in our slides too. All right, ladies and gents, good luck with this one, and I'll see you in the next lesson.